This video is for 12.2 homework. So if you have any questions on those homework problems, be sure to follow along with this video. So number one tells us that a geodesic dome is made up of triangles. Maybe you've seen one of these buildings before that's made up of triangles, most of which are equilateral, so they're the same on all sides. The surface uses less materials and allows for more open space than traditional buildings. An equilateral panel of a geodesic dome has a base of 6 feet. So I like to draw the triangle to help visualize what it says. So the base is 6, and then it has a height of about 5.2. So what is the area in square feet? So our formula is base times height, but that gives us a quadrilateral, a parallelogram. Then we have to cut it in half in order to get it back to just the triangle. So if I do 6 by 5.2, that's giving me this parallelogram. We want to cut it in half to get that triangle. So we're going to do 6 times 5.2, and then we cut it in half, divide by 2. Don't forget about that decimal, and that will give you your answer in square feet. So number 2 is kind of an interesting question. So it says that we have a triangle that has a height of 3 and a total area of 9. So we don't know what type of triangle this is. So it has an area of 9. So this is the height. So the things we do know is that 9 square meters equals, so it's base times the height is 3, and then we always divide triangles by 2. So it asks, is there a unique triangle represented by these measurements? So what that means is there one specific triangle that this has to be, or can this look like several different triangles? So first let's find what is this base, and then talk about, is there more than one way this triangle could look like? So when we're working backwards, we do everything backwards and opposite. So if we were normally doing this, we would do base times height, divide it by 2. So we want to do the last thing first. So the opposite of divide by 2 is to times by 2 on both sides. So now we have 18 equals B3, since this cancels out, because this is 1/2 times 2 equals 1 whole. 9 times 2 is 18. So we're left with 18 equals B3. Now we want B alone. So the opposite of timesing by 3 is to divide by 3 on both sides. So 18 divided by 3 is 6 equals B. So let's plug this back in and double check ourselves. So we're saying the base is 6 and the height is 3. 6, so base times height, 6 times 3 is 18. That gives me a rectangle. Cut it in half is 9. So 6 is my answer. So let's decide, is there only one triangle? Would it look like exactly like that, or can I make a different triangle? So what if I have a right triangle that looks like this? The base is 6, the height is 3. 6 times 3 is 18. Cut it in half is 9. So there is more than one triangle. So we know our base is 6 across, and we go 3 meters up. My other vertex could be anywhere along here. It could be, let me grab a different color here. We could have a triangle that looks like this. We could have a triangle that looks like this one. We could have a triangle that's a right triangle. As long as the base is 6 and the height goes 3 up, that triangle, we could have it all the way over here, and it's 3 up, 6 over, and connect like that. So there is not one set triangle that this has to look like. As long as the base is 6 and that right angle up is 3, that point can be anywhere along that 3 meter line. It just has to be 3 up. So let's see. So we're definitely saying no, there is not a unique triangle. So this one's gone, this one's gone. Our answer is no. So why are we saying no? The base of the triangle is 6 meters. That sounds true. This says the base of the triangle is 3. Well, that's not true. We know the base is 6 because we figured that out here. So let's make sure all the rest of this information matches. There are an infinite number of triangles with this base and height, right? We could put the point here, 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 here. We could put the point how many different places along that 3-meter line up. So yes, there's an infinite number of triangles. We can't count all the triangles that would have a base of 6 and a height of 3. The vertex opposite the base, so the point up here, can be anywhere along this line that's 3 meters above the base. So our correct answer is this one here. That is all completely true. Okay, number 3 says an isosceles right triangle. So isosceles means that 2 of the sides are the same and it has a right angle. So this side is the same as this side. I need to make that one just a little longer. And then we're connecting. And here's our right angle. So isosceles, I always remember that there's these 2 S's here. The 2 sides are the same. Has a base and a height that are the same. So the base and the height are the same, which is what we drew. If the area of the triangle is 32 square centimeters, how long are the base and the height? So we know the total is 32. We know the base and the height are the same. So we need to remember these are the same, and then we'll divide it by 2. So let's start and get rid of this divide by 2. So the opposite of divide by 2 is to times by 2 on both sides. So this cancels out. So 2 times 2 is 4. 2 times 3 is 6. So we're left with 64 equals BH. So B and H have to be the same thing because they're an isosceles triangle, and it tells us they're the same here. So what times itself equals 64? So see if you can think of a factor that you'll multiply by itself. So for example, if I picked 4, 4 times 4 is only 16. So it's not 4. So I need to come up with a number, base times height, that are the same, that equals 64. Okay, number 4. The diagram shows the outline of a triangular foundation of a front porch. What is the area of this foundation? So our formula, we take the base times the height, but that gives us a parallelogram here. So we want to cut it back in half. And so let's plug in what we know. So here's our base is what it sits on. So 15.5 times the height is off this right angle right here is 12. So we're going to do 15.5 times by 12. Don't forget about your decimal. And then we're going to divide that by 2. And that will tell us our area in square feet. Number 5 has this triangle here. So again, base times height divided by 2. So what is the base? The base is 6. What is the height from the right angle? The right angle is here, so the height is 3. And then we have to cut it in half from that rectangle to get our final answer here. So same thing here. So base times height, then divide it by 2. Okay, here's our base, and our height is out here coming from this right angle right here. So base times height, and then we're going to divide it by 2. Actually, let's come back to this one. I'm going to help you with this one a little bit. So 3.5 divided by, or times by 5. So here's 25, 15, 16, 17. and I have 1 decimal place. So I got 17.5, and I want to cut that in half. I know that 2 is not going to go evenly into this because it doesn't end in an even number. So it already has a decimal. If it doesn't have a decimal, just add a decimal and a 0. Then you'll be good to go. Since this already has a decimal, I just need to add the 0. So then I do my multiplication and finish that problem. So using those decimals and add on the zeros, so we don't want to just leave it and have remainders. We want to put them in decimals or fractions. Since this gave us our answer in decimals, we want to put our answer in decimals. Okay, so this one, here's our base. Here's our height. So 3 times 5 is 15. And then we're going to take 15 and divide it by 2. So I know it can't go in there evenly. So I'm just going to add a decimal and a 0, and now it will. So don't forget about that decimal though. So it's not 150, it's 15.0. Hey, which one has the largest area? So we've got to solve each of these and find the one that is the largest. So base times height, and then divide it by 2. Here we have base times height, divide it by 2. Here is base times height, divide it by 2. And base times height, divide it by 2. So see which of these is the largest once you've done that work there. Number 10 says the base of a triangle is 6.4 feet and the height is 5 feet. How many square feet is the area of the triangle? So when it gives you words, I like to draw out the picture so I can visualize what I'm working with. So we're going to do base times height, and then we'll divide it by 2. A triangle has an area of 42 square feet. So this time we know the area is 42. The height of the triangle, so to get from the tip to the bottom here in this right angle, is 4 feet. We're looking for the base. So our formula for a triangle is area is base times height divided by 2. So let's plug in what we know. We know the area is 42. We know the height is 4, and we're looking for the base. So the base times 4, and we always have to divide by 2. So we've got to keep that part. So working backwards here, the opposite of divide by 2 is to times 2 on both sides. So this cancels out. So 2 times 2 is 4. 2 times 4 is 8. So 84 equals B4. Now we want to get B by itself. So divide, opposite of times 4 is divide by 4 on both sides. So the 4's cancel out. So when you do 84 divided by 4, that will tell you the base of this triangle. So it sounds like it has a really long base, and then it's only 4 feet tall. So we've kind of got a triangle that's going to look something like that. Number 12, the height of a triangle is 1/10 of its base, and the base is 12 inches. So we know this is our base is 12, and it says our height is 1/10 of the base. So the height equals 1/10 of means to multiply. In this case, 1/10 of this is 12. So 1/10 of multiply by 12 will tell us the height. Then our final question asks how many square inches is the area of the triangle. So first we need to find 1/10 of 12 and then use that to find our final answer. So let's start with 1/10 times 12, 1/10 of 12. So 1 times 12 is 12. 10 times 1 is 10. So I know that this is improper, but I'm actually going to leave it like this for just a second because if I make it a mixed number, 1 and 2/10, and I can simplify that, when I go to times it by 12, I just have to turn it right back into this mixed number. So I'm just going to keep it this. So my answer here is that it is 10 or 12 tenths. So a tenth of 12s, right? If I take this thing that's 12 and cut it up into 10 pieces, each piece is 1 and 2/10. So a little bit, so 10 times smaller than 12 is 1 and 2/10. So we're going to do base is 12 times by the height is 12/10 and over 1. So it looks like I can do some simplifying here. So what goes into 12 and 10 is 2. So that goes in there 5 times and 6 times. So 6 times 2 is, 6 times 12. So we're going to do 6 times 12, 1 times 5. So 6 times 12 is 72. And then we've got over 5 here. So 72 over 5. So we want to do 72 divided by 5. So add a decimal, see how many times it goes in there. Is, let's see, 1 time, and that's 5. Sorry, I kind of lost my train of thought there. And then it goes into 22 4 times. That is 20. And then we have a 2. And okay, so see, by adding this decimal and this 0, it makes it go in there a nice even time. So 5 goes into 20 4 times. So 14.4 is not our final answer. We've done base times height. We did 12 times 12/10 was 72/5. So we found that base times height is 14.4. But remember, that gives us a whole rectangle. So now we have to cut our rectangle in half, and that will give us our final answer. So we're going to take 14.4 and divide it by 2 to get our final area of this triangle here. Okay, number 13. So we've done some of this today. So this should be pretty quick. What is the value of x? So we want to get x by itself. So this says that we're going to times by 64. So the opposite of times by 64 is 2. Divide by 64. So 8 divided by 64. So now this is not 64 divided by 8. That would look like this. 64 divided by 8 equals 8. And if I plug that back in, 64 times 8 is not 8. So this is not what we're doing. We have 8 over 64. So think of a number that can go evenly into 8 and 64 and simplify it until there are no other numbers that can go into the numerator and the denominator. Okay, and our last one here is number 14. So we want to find the value. So before we do this, we need to make them improper. So 4 times 2 is 8 plus 3, 11 over 4, divided by 4 times 2 is 8 plus 1 is 9 over 2. Our denominator stays the same. Now we want to, so we can't do 8 or 11 divided by 9 very easily. We could do 4 divided by 2, but 8 over 9 is, or 8, my goodness, I keep saying 8. There's no 8. 11 divided by 9 is not a very nice problem. So we can make it nice by doing copy dot flop. By multiplying the problem instead, it becomes much easier to do. You can also simplify the 4 and 2 ahead of time if you would like. So go ahead and do 11 times 2, 4 times 9, and then simplify your answer. So we want it in the simplest form. Hey, if you have any other questions on those, please let me know and we can set up a time to meet together.